All right, so number 33, we have a person on a hill, a woman. So we have a woman on the hill, and then she sees a flagpole. The American flag on it. And she has two angles, right? From her point of view, from her vantage point, she can see the top of the flagpole. And if you measure that angle with the eye level, which is parallel to the ground, she makes an 18-degree angle of elevation. Did I share my screen? Very good question. I thought I did. I did not. So I'm drawing stuff. You guys aren't seeing it. Give me 1 second and I'll share my screen. Thank you for that. I didn't know I was not recording it or sharing it. So this is what we have. We have a little woman here on the hill looking at a flagpole. She looks up 18 degrees angle of elevation of 18 degrees. And then she has an angle of depression looking downward. Let me see if I get, yeah, looking to the base of the flag, it's 14 degrees, okay? And then we may have different numbers for this, but she says that the flagpole is 45 feet tall. So this might be different for everyone else, but again, the idea of the problem is very much the same. And the question is, find her distance x from the pole. So we want to find x. Okay, so this one seems a little bit more involved than the previous ones we've done. The unknown is the distance from the flagpole to the woman. But what we do know are these things. We know the angles that she makes of elevation and of depression. And we know that this has to add up to 45 feet. So this is how we approach it. This is how we approach this. We don't know what this side is, and we don't know what these sides are. But what I do know is if I add up these sides, it must add up to 45 feet. I should also recognize that this is a 90-degree angle, so I can use some kind of trig function here because I have two 90-degree angles at two right angles. Now the trick here, or the technique is to represent the unknown values with the unknown value. So for example, if I call this, I can call this an unknown variable as well. I'm gonna call this A for now. And I can call this another variable that I don't know. I'm gonna call it B. You may be thinking, but now you're including more variables to find out. But just hold on 1 second. We know for a fact, we know that what? We know that A plus B equals 45. That's what we know, right? We know that this side, whatever that is, plus this side, whatever that is, has to add up to 45 feet. Now what we're going to do is look at each triangle individually, okay? So I'm going to look at the big one here, the top one, and then I'm going to look at the bottom one, okay? So this is top triangle. and this is bottom triangle. In this one, we have an 18-degree angle. We have X, and we have A. In this one, we have a 14-degree angle. We got X, and we got B. Now, look what we're going to do. We're going to express, this is the key here. Express side A in terms of X. Key phrase here is in terms of X. And I'm going to do the same exact thing here now for side B. Express side B in terms of X. What that means is I want to represent I want to represent this side with X involved in it. Now, what kind of trig function relates the angle, opposite side, and the adjacent side? What trig function relates those three quantities together? Tan, that's right, Chen. Tan of 18 degrees equals A over X. So I'm almost there. I want to solve whenever you hear the word or the phrase in terms of a variable, so in terms of X, I want to get A as a function of X. I want to get A alone. So what's the only thing else that I need to do is I need to multiply both sides by X. I do so because I want to get rid of the X, and look what happens. I get A by itself. So A is equal to X times tan of 18 degrees. So now I can replace, instead of calling this A, I can replace it with this expression, X times tangent of 18 degrees. So great, I completed the objective that I have of expressing side A in terms of X. I did it. Now I'm gonna do the same thing for the bottom triangle for side B. I have the angle 14 degrees. I got the adjacent side X, and I got B, the opposite side. So then I say tangent as well. Tangent of 14 degrees is equal to B over X, opposite over adjacent. I want to get B by itself so I can have it in terms of X. So find B, multiply by X to get B by itself. And when I get that by itself, what do I get? B, I get X times tangent of 14 degrees. So look what I did, guys. I got A by itself here in terms of X. A is actually just X times tangent of 18 degrees. So I can replace this by saying this is X times tangent of 18 degrees. I can just replace it with that. And the same thing goes for the B. I have this X times tangent of 14 degrees. And what do we know in the beginning? We knew that in the beginning, A plus B equals 45. So what am I going to do here? I'm going to say A plus B equals 45. But I know what A is. A is X times tangent of 18 degrees. And B is X times tangent of 14 degrees. And this equals 45. I am not going to use my calculator as of yet. I'm going to use it at the end. Now, what can we do? I want to get X, right? I want to solve for X. That's my main objective right now, because that's the overall objective, to find the value of X. So I want to solve for X. So what can I do here, guys? If I want to get X equals some expression, I got X tan 18 plus X tan of 14 equals 45. So what must I do? I want to get x's. I want to solve for x. Divide? No, not yet. I can't divide yet. What I have to do is I have to factor x. The step here is to factor out x. So factor out x. This is a algebraic technique. So when you factor out the x, look what's left. Tangent of 18 degrees, that's something, right? Plus tangent of 14 degrees. That's another value here. Do you guys see that? That's a very um, necessary technique to be able to do. Factoring is essential. And now you have x multiplied by a sum. So what do? Now you divide. Now you divide both sides by the expression tangent of 18 degrees plus tangent of 14 degrees. Now you divide by that on both sides. And so then this whole expression now, because it's all together, right? That cancels on the left side. And I'm left with x is equal to 45. And all of that is divided by tangent of 18 degrees plus tangent of 14 degrees. And now you put this in your calculator. And just be very mindful of how you do it. So let me do that as well. So you have to be careful when you plug this in. Let me share my screen. So here we have, make sure you're in degree mode, and I'm in degree mode. So I'm gonna put, create a little fraction here. And then the top is 45 and the bottom is tangent of 18 degrees plus tangent 14 degrees. Press enter and you get 78.3633 feet. And so that's how far the woman was to the flagpole. Yep. So oh, can you show again how to get the fraction set up? Yeah, so if you have a TI-84, yeah, I also learned this from another student a while ago. I didn't know you can do this on this calculator. You can though. You use alpha, so the green button. You press alpha and then you press y equals. And then once you do that, you have this like option here. You have the first option is the fraction version. And the second option you can do mixed numbers. You can do from fractions to mixed numbers. You can go so there's a lot of techniques. There's a lot of little options here, but yeah, it's only the first one. And then you have your fraction you can set up. That's pretty convenient, pretty nice. Okay. So any questions about how we set it up to find the answer? So the answer again is 78.36 feet. This wasn't an easy one. It wasn't, because it at first it seems like how do you relate so the hardest thing for most of these kind of problems is to make the connection with the unknown and the known information. So this is known, this is unknown, this is known, this is known. And what you have to do is do the best you can to find that connection between the unknown and the known information. And so that's why we had to do this intermediate step here into representing these values in the unknown value that I'm originally trying to find. And because I was able to do that, then I can create, this is the crux of the problem. I can create an equation where the known information is connected with the unknown information. And then from here on out, it's just an algebra step. Okay, so that's number 3. And then Felipe, number 33. Number 33. Number 33, we have a triangle. This is A, this is C, this is B. I have theta. I got A, I got C, and I got 38. And it says, assume that A for your numbers might be different, but my numbers are 125 and 148. And it says find the indicated value of theta. So, okay, I need to find theta, right? That's what I want to find. See, yeah, C could be very different for others for your specific problem, but the idea will be the same. If I solve it with these numbers, it will be the same for your numbers. Now it says use either law of sines or the law of cosines as appropriate. Right now, I don't know this angle, but I do know what? The side opposite, right? So that's what you have to realize first. What's the side opposite? So angle theta is associated with the opposite side of 148. I also know what? I also know 125. The problem is I don't know the opposite side to it, the opposite angle. I don't know. So this is also a mystery. So could I use the law of sines? Can I use the law of sines at the moment? I have this angle opposite. I got this angle, but I don't have the opposite either. So I can't use the law of sines as of now. Not as of now. Because remember, for law of sines, you need two things. You need two sides and two angles, and they have to be pairs of opposite sides to the angle. But in this case, I have let's call this B. If I were to pair this up, this is unknown, this is known, this is known, but this is unknown. So I would set up a law of sines proportion with two variables. That's not good. I can't really do much with that. Can we use law of cosines? That's the only other option. Can I use the law of cosines somehow? And remember the law of cosines, what do you need? You need 3 sides and 1 angle. I have 1 angle. My angle is 38 degrees. I got this side, but I don't know this side. But that's okay because I only have 1 variable, which means I can set up the law of cosines so that I can figure out B. And once I figure out B, then I can use the law of sines. So this is a multi-step problem. You need to use the law of cosines first to figure out the missing side. Once you have all 3 sides and you have one of the angles, you can figure out the other angle using law of sines. So always try your best. I know it's not easy, but always try your best to envision or to plan out before you even attack a problem. Try to envision what are the steps or what you may have to do. And it's hard to see things ahead of time, but that's a skill in itself to develop, right? When people play chess, what do? They try to figure out a few steps ahead of the opponent and of the game. It's the same thing with the mathematics, especially with these kind of problems. You have to try to find a way to see, okay, how do you get to that? I want to get to this. I want to get to this angle. So what do I have to do first? Sometimes it's not just one step. It might be 2, 3, 4. It depends on how complicated the problem is. Okay, so let's apply the law of cosine. So we can apply this. And the law of cosines goes as follows. We got b squared, right? Remember, we have three versions of this. So b squared equals, and then we have the opposite, we have the sides that aren't opposite the angle. So first of all, we have to recognize that this angle is opposite the missing side, right? So we know for a fact that b and is going to be related to cosine of 38 degrees. And then we have a squared plus c squared minus 2 times a times c. I know what a is, I know what c is. So now I just have to plug in. So b squared is equal to a squared, which is in my case 125 squared plus 148 squared minus 2 times 125 times 148 times cosine of 38 degrees. So at this point here now, it's just calculator question. So let me share that. So the calculator tells me to write 125 squared plus 148 squared minus 2 times 125 times 148 times cosine of 38 degrees. Press enter and I get b squared is equal to 8,372.602117. And what I want to do is I'm going to take the square root immediately. So I'm going to take the square root is second x squared, and I'm going to take it of the answer. So I'm going to do second and then this negative sign in the very bottom. So now I'm taking the square root of my previous answer. I don't have to plug it in again. And I get that the b value is 91.50192411. So that's my b value. So I got my b value. I know what it is. And let me just say, I think it tells us to round to 2 decimal places. So we can round to do that 2 decimal places. I'm just going to leave it like this for now. So b is equal to 91.50192411. So what does that mean? I know all the sides. Now apply law of, so this is the first thing I do. This is the first step, law of cosines. And now I can apply law of sines. Apply law of sines. What's the law of sines tell me? It tells me that if I write, and what angles am I going to use? I'm going to use angle missing side. Oh, wait, angle not missing side. I know the side. So this is angle with known side, missing angle with known side. So then what is that going to look like? It's going to look like 91.50192411. This is the known side. This over sine of 38 degrees, according to the law of sines, is equal to 148, the known side, opposite the unknown angle, sine of theta. So this is the setup. Once I have the setup, now I can solve using algebra. Cross multiply, because I want to get theta at the end of the day, so I want to solve for theta. Apply law of sines to solve for theta. Now when I cross multiply, I get 91.50192411 times sine of theta. This equals 148 times sine of 38 degrees. Again, I want to find theta, so I divide both sides by 91.50192411 on both sides. So then these cancel, and I'm left with sine theta is equal to 148 times sine of 38 degrees. And all of this is being divided by 91.50192411. And so I want to find theta. So I need to find theta sine inverse of the expression 148 times sine of 38 degrees all over 91.50192411. So I'm going to apply the inverse trig function for that. And Tiffany already got 84. Let me check. So I'm going to do sine inverse. So second sine. Then I'm going to do the fraction expression. And I got 148 times sine of 38 degrees over 90. Oh, I'm just going to put answer here. So I'm just going to put second, and then I'm going to put this negative sign on the bottom. So that gives me the previous answer, and my previous answer is what I want to place there. And then when I plug it in, I get exactly what Tiffany got, which is theta is 84.7488 ... and then round to nearest decimal place, 2 decimal places. So 84.75 degrees would be the answer. Okay. Okay. Any questions about this problem? This problem required you to first use law of cosines to find the missing side. And then once we found that missing side, we can create this law of sines proportion and solve for theta that way. So this is a two-step problem. Any questions about number 33? Is that clearer now? Does that make more sense? Do you guys see what's expected of you to solve these problems? Hopefully it's not as bad as it was. 34 would be the same idea. 34. So we have A is 17, C is 12 for me, and we have angle C. Round your, yeah, it would be very much the same. But actually, no. 34, you don't have to use two of the laws. You just have to use law of sines. Felipe, it should give, it's, yeah, we just did it on the calculator. So the calculator gave us the angle. So if I put that your expression sine inverse, so sine inverse of 140. Okay, wait, this has to be, put it as a fraction, 141 times sine of 38 degrees over 75. Your number is 75.68765,378. And you close your parentheses, you enter, and you get, oh, the quit go to. So there's a problem. There's a problem with your numbers. Wait, so what numbers do you have? Because this looks like it's outside of the range for sine. Do you have 141? And what else do you have? Do you still have 125? You still have 125? Okay. So let me 125 squared plus 141 squared minus 2 times 125 times 141. And it's the same angle too. Is it 38 degrees? Yeah, okay. Um, so I don't know where you got the 75.6876 from, but when I did it, I got 42 instead. So I got this number instead. Hold on. Yeah, I know, Felipe. You're doing it, but I'm saying what I'm saying is you made a mistake because the bottom side should not be 75. It should be 42.89 or 118846. It shouldn't be 75. And I there's a mistake here. Hold on. 141 sine of 38 degrees. That's very strange. 87.91. Is that what you got, Tiffany? And then 80. Yeah. Hmm. Hold on 1 second, guys. Let me see. Sometimes these things happen where there's like a discrepancy, but there's always a way to figure it out. Yeah, Tiffany got the right answer. Thank you, Tiffany. So okay, that's number 33, and then 35, 30. Okay, so Tiffany, 34 is the same idea, but I'm not gonna do 34. I'm just gonna show you that you don't need to do the double law thing. So let me share my screen here. So a lot of this is about setting up the correct answer. I mean, setting up the right equation. And then the rest of it is just algebra. So if you look at number 34, 34 looks like this. We have angle theta, and we have this angle, and we have A, and we have C. In my case, A was 13, C was 11, and C here is a 45. Do you see here that this angle is paired up with this opposite side? And do you see that this angle is paired up with this opposite side? And the only thing you have unknown is theta. So you can set it up as 11 over sine. So I can use law of sines. So you have 11 over sine of 45 degrees. This equals 13 over sine theta. And I can solve for theta using law of crossing out, cross multiplying. Do you see that, Tiffany? So number 34, you only need law of sines. You don't need law of cosines. So I think the hardest problem from these last few problems here that you have is number 33, because number 33, your answer was still incorrect. Yeah, it's try that again. Make sure your numbers are correctly set up. It's all about the setup. Number 33 was harder because you had to apply law of cosines and then law of sines. But 34, you only apply law of sines. And then 35, number 35 is also just applying law of cosines in this case. So number 35, no, number 35 is easier than the one that we just did. 33 was the hardest one. 35 is not supposed to be, and 34 is not supposed to be hard because it's only a one-step problem. You have an angle 40.3 degrees in my case, and then A is 2.92 in my case, and B is 3.46 in my case. And then they're asking us find the distance across the lake. And so we have like this lake here, right? We have some lake here, and they want to know the distance across it. So I don't know what that is. But like I said, we have three sides, one, two, three sides, and we have an unknown angle. We have a known angle opposite the unknown side. So what do I have to do? Apply law of cosines only. That's all I need. I don't need to do an additional step. So apply of law of cosines. What is the formula for this? X squared is equal to 3.46 squared plus 2.92 squared minus 2 times 3.46 times 2.92 sine of, pardon me, not sine, this is law of cosines. So let me move this over here, and this becomes cosine of 40.3 degrees. And then this just becomes a calculator question. So once you set that up, you use your calculator. Okay. So I got 3.46 squared plus 2.92 squared minus 2 times 3.46 times 2.92 cosine of 40.3. And you get x squared is equal to 5.08721 dot dot dot. And then I just want to find, so this is the squared version of the side that we're missing, and I want to find square root of that. So I do second, and nope, that's not what I meant. I want to do second square root and then second answer. And when I press that, I get 2.25. So I get 2.255 dot, 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 dot. And that should be the answer. Oh, okay, Tiffany, I'll be right there with your question. Yeah, so yeah, you round to the nearest two decimal places, right? If I'm not mistaken. Usually, yeah, round to two decimal places. So in this answer, it would be 2.26 as my final answer. Okay, so number 34, that's a very good point, Tiffany. It says find the angle, right? And the angle must be uh, bigger than 90 degrees, right? And then when you do it, what do you get? When you do this, right, theta is what? 61, right? 61.226. But obviously, this angle is expected to be obtuse. It's bigger than 90. Now, so then how do you compare the two? Or how do you make sense of this answer if this answer is not what you expect it to be? Now, you have to recall, though, the reason why you get this answer is because you use sine inverse, and you have to understand that sine inverse gives you a certain range of values, and those range of angles exist in quadrants 1 and 4, but this angle is not in quadrant 1 nor in quadrant 4. So what you get here is not the angle that you want. You get the what? You get the reference angle. So then what do you have to do? So you do have to do one more step for this. You have to do one more step in finding the actual angle that you're interested in. So sine inverse gives you this angle, but I want an angle that's associated with this angle, reference angle, that happens to be bigger than that's bigger than 90 degrees, but less than 180 degrees. So yes, you have to subtract. So the angle that you're interested in, theta, is 180 degrees minus the angle, the reference angle. So that's that additional step you had to make. So you always have to recall and remember that sine inverse only gives you angles from quadrants 1 and 4, and that's between negative pi over 2 to pi over 2, or from negative 90 degrees to positive 90 degrees. But I want an angle to be in the second quadrant, bigger than 90. So then once I find the reference angle, which was what the sine inverse gives me, you do 180 minus that angle to find the actual obtuse angle. So always be mindful of that. Yeah, theta for my question is 56. Yeah, no problem. So 56.685. Okay, guys. So does that make sense? Using law of sines, you have to be mindful of the fact that you can have an angle that's bigger than 90. So what you have to do is after you find sine inverse, do 180 minus that sine, that angle. Okay. All right. So Felipe, I'm not gonna do the whole thing, but I'm gonna give you guys just the idea of how to solve these problems. Again, this is supposed to be for you guys to try your best at figuring it out. So number 6, right? So number 6, it says find sine, and they're telling you how to do it for number 6. Like they tell you how to try to begin this. And we've done problems like this last time. So find this, right? I want to know what this is. And it tells us let theta, they're telling you call this theta. And they're saying theta is equal to what? Cosine inverse of 8 over 17. They're telling you to write it that way. And then it says complete the triangle below. Because that's what you're supposed to be doing anyways. You have to create a right triangle. And then this is theta. This is the angle theta that they give you. And now what the only thing you have to do, this is the hardest part of this question, is to do this. To make the step to write this as cosine of theta and say that this equals 8 over 17. Right? And then once you have this, then you have what? The adjacent side. You have the hypotenuse. So then what does that mean? I got the adjacent side is 8 and I got the hypotenuse is 17. And then can't I figure this out? It's one of the Pythagorean triples, right? 8, 15, 17. This is 15. And you can find this out if you don't remember it using Pythagorean theorem. And now this becomes sine of what? Of theta. So what's sine of theta? Opposite over hypotenuse. So that was it. 15 over 17. So the answer is 15 over 17. And of course, your numbers might be a bit different, might be the same. But the idea, guys, that's the idea is what's important. How to solve the problem is the important part. It's not necessarily what the answer is, it's how you get the answer. So if you know how to get the answer, then the numbers at the end, they're just, they're not as relevant. And okay, Felipe, number 32, if you look at it, the way it's set up, they give you two sides, they give you the angle, and you're missing one side. So that's three sides, one angle, law of cosine. So we've done problems like this already. So I'm not gonna do it again. Yeah, you have to find x. You have to apply law of cosines. You have to set up this again. This is a problem. You set up the problem using law of cosines, and then you use your calculator. And the hardest part of this problem is to set up the correct equation. If you have the correct equation using the law of cosines, then you use your calculator to find the rest. So number 32 is strictly law of cosines. So you would write correct. So you would write x squared equals 12 squared plus 12 squared minus 2 times 12 times 12 times cosine 40 degrees. Put that in your calculator, take the square root of that, and then that will be your answer. We've done a problem like this already. Number 32 is like doing number 33, but except we don't have to use law of sines after. We just use law of cosines. Okay. So number 32 was the law of cosines. I don't understand your question, Philippe. What do you mean? What I got to do with? What do you need to calculate? Well, you need to calculate the you have to calculate this. So if you got number 32, right? And you got this triangle here. And they're telling you this is 12, this is 12, this is 40, this is x. So you use law of cosines because I got three sides and one known angle, and I'm missing one of the sides. So then you use x squared equals 12 squared, like I just said, 12 squared minus 2 times 12 times 12 times cosine of 40 degrees. You have to calculate this because I can't do it in my head. I got to use my calculator. So I have to calculate that. And you have a calculator to do so. And then from there, you can find x. So this is not, doesn't take too much time. Again, the hardest part is getting to here. This is the hardest part. Identifying the fact that you're using law of cosines for this. Once you have that, then it's just calculator work. No problem. And then number one, this is the last one, guys. Number one for Chen. So number one, it says a plane is within sight at an elevation of 35,000 feet. The pilot would like to estimate her distance from the gateway arch. She finds that the angle of depression to a point on the ground below the arch is 19 degrees. What is the distance between the plane? Okay, so it looks more confusing than it is. So we have this arch, right? I'm gonna try to draw it like this. Right, this is in St. Louis in Missouri. Um, the pilot would like to estimate her distance from the gateway arch. So we have a plane. Cannot draw for life. So we have a plane here, okay, and the elevation is 35,000 feet, and she would like to estimate her distance. So she wants to know how far away her distance is. So this is x. I want to know how far away the distance is to the gateway arch. She finds that the angle of depression to a point on the ground below the arch. So then the point on the ground below is right here, right below. I'm assuming it's right below the top portion. And so if I draw a line straight to this plane, this angle of depression is 19 degrees. And then what do I have? What do I have? What kind of triangle do I have? I got 35,000 feet. Do you see that? This is a 90-degree angle. So this side is the same as this side. This is the missing side, x. I don't know what x is. And I know this angle here to be what? 19 degrees. So do you see how I was able to create this right triangle? And now what angle or what trig function relates the angle, the opposite side, and the adjacent side? What angle does that? I mean, what trig function does that? And it's tan. Tan of 19 degrees equals the opposite side, which is 35,000, all over x. And then you can cross multiply. You can multiply by x on both sides because I want to get x, right? So I get x times tan of 19 degrees. That equals 35,000. Divide by tan of 19 degrees. Divide by tan of 19 degrees. And I get that x is equal to 35,000 divided by tan of 19 degrees. The point on the ground. Okay, and then what? And then you get you put this in your calculator and you get 35,000 divided by tan of 19. Whoops, change it to degrees. So 35,000 divided by tan of 19. And so I get 1,001,647. So this is actually, pardon me, this is actually part B. What we calculated was the distance between a point on the ground. So this is the point on the ground, and yeah, we found the distance between the point on the ground and the height. I mean, we found the distance from the point on the ground to the plane. But part A is asking for the distance between the plane and the base. So that's very strange. So we found B first, and B will actually will help us find A. Because what is A? A is the distance between the plane and the base. So what we found was the horizontal distance from the base to the plane, but now I want to find the direct distance away. So then you have to use the Pythagorean theorem for this. So then let's see the Pythagorean theorem. So once we found what this is what? 1,001,647. Then I want to find this missing side here. I'm gonna call this, let's call this C. So this is 35,000 squared plus 101,647 squared equals C squared. And then you put this in your calculator. A lot of this is calculator work. And you square root that. And when you find the square root, you get 107,504 points, ... So yeah, it's just rounded to the nearest foot. So it's kind of strange that part A was written first and part B. You could have also done, actually, you could have done part A first, because you could have set up a different trig ratio. You could have set up that this is 35,000, right? And found C using this using sine. You could have used sine of 19 equals 35,000 over C, and you would have solved for C. So I just did it the more roundabout way. I first figured out what X was, which is for part B. And then I used the Pythagorean theorem. I didn't have to use the Pythagorean theorem. I could have also done this. So this is alternative solution. I could have set it up as sine of 19 degrees is equal to 35,000 over C. So then that means that C would have been 35,000 over sine of 19 degrees. And then I would have gotten the same thing, 107,504, if I would have done it using this way. And I'll try it just in case. And I get the same exact thing. Okay, so either way, This question we have to find B. No, actually, no, Chang, we didn't. That was my misunderstanding. You could do part A or part B first. It doesn't matter which way. It just depends on how you see it, right? So you could have found X first and then found C, or you could have found C first just using sine, and then you could find X and C individually. You could find it individually. Felipe, yes, there will be. This is the last homework. So for due tomorrow is the last homework. Okay. All right, guys. So we have about 45 minutes left of class. I hope this was helpful. I really hope this clarified a lot in terms of using trig, using law of sine, using law of cosines. At the end of the day, I want you guys to understand what you guys are doing, not just bombard you with just lots of information here. Because as you can tell from this whole semester, we've gone through a lot of material, and it does take time to have everything understood in your heads, clarified. It takes a lot of practice, guys. With all of this stuff, it just takes a lot of practice to see different scenarios, different situations, knowing how to react to different kinds of problems, the way that they're set up. But eventually, if you do enough of them, you start to see that they're kind of the same thing again and again. So the last thing I want to touch upon today with you guys is solving. Solving trigonometric equations. This is the last thing of the semester. So I want to solve trigonometric equations, and we'll start very slow, basic. So for example, I'll give you an example of what I mean. And you've done this already. So yeah, Felipe, it went quickly. Hopefully it went quickly to some. I know for others it might be, including me, it might have taken a little bit longer than anticipated. So this is an equation. This is an equation for trig, a trigonometric equation. I want to solve for theta. Now, how do I get theta? Don't I do this? Theta, isn't this sine inverse of rad 3 over 2? And then what is sine inverse of rad 3 over 2? What's sine inverse of rad 3 over 2? Sine of what angle gives me rad 3 over 2? Yeah, it's 60 degrees, right? And we're going to be working exclusively when we talk about trig equations. We're going to be using theta or the angles to be in radians. So the radian version is rad 3, pardon me, it's pi over 3. So we got it. We got it. We got one answer. Now the thing we're going to have to start to consider again is the fact that this angle theta can be an infinite number of possibilities because of the cyclic nature of sine. So not only do I have pi over 3 as one of the answers, I also have pi over 3 plus 2 pi, or 360 degrees, right? So I actually have more than this. I have plus 2 pi. And I can add 2 pi, I can add another 2 pi, which is 4 pi. I can add another 2 pi, which is 6 pi. So actually what's going to happen, guys, is this is going to be 2 pi n, where n is an integer. You guys follow me? Now, another thing you have to keep in mind is the fact that this is in what? This is in quadrant 1. Let's draw this little thing again here. So the angle that I'm considering is pi over 3. So it's this angle right here. Pi over 3. And let me draw the unit circle. So at pi over 3, again, at pi over 3, what are my coordinates? My coordinates are um, 1/2 comma rad 3 over 2, correct? And remember, this is the sine of the angle. Now, where else on this unit circle is the y coordinate rad 3 over 2? It's also going to be here. And in this case, my coordinates are -1/2 comma rad 3 over 2. And this is sine. So how do I get this angle here? I want this angle here now. How do I get this angle? This kind of comes back to that problem that we did where we had to find the reference angle, which is 60 degrees. This is my reference. My reference angle. And again, this is in the first quadrant. I add 2 pi and I get back to the same point. So this represents all of the possibilities where the angle is in the first quadrant. But the angle in the first quadrant is not the only angle that would give me a positive rad 3 over 2. I also have angles in the second quadrant. So this is where we have an additional answer. And that's when you do what? When you do 2 pi minus pi over 3. Pardon, not 2 pi. This is pi. So it's going to be pi minus pi over 3, which is 2 pi over 3. This is like saying, hey, if I have an angle 60 degrees in quadrant 1, then the angle associated to 60 degrees in quadrant 2 is going to be 180 minus 60 degrees, which is 120 degrees, and that's 2 pi over 3. So I actually have two answers here. I got pi over 3 as one of the potential answers, and I got 2 pi over 3 as one of the answers. But of course, I need to add it by 2 pi over n, by 2 pi n. So guys, this is my answer. And what I call this my general solution. My general solution is composed of an infinite number of solutions. There's an infinite number. There's an infinite number because n could be any integer. So I can make this 100, for example. And so my other solution would be pi over 3 plus 2 pi times 100, which would be 200 pi. That's another solution. As much as I can change n, I can create a new solution. That's why it's an infinite number. And let's suppose I want to find particular solutions. So what if I want to find a particular solution? Particular solution on the interval 2 pi. So this is when I specify, for particular solutions, I have to specify an interval. So now the question is, how many solutions do I have on the interval from 0 to 2 pi? Well, if I just go around the unit circle one time, I only have two solutions. I only have this solution here and this solution here. This angle here is, so my theta here would be pi over 3, and my other angle would be 2 pi over 3. And that would be it. Okay, so that's how you solve this And this is one of the basic ones. This is one of the simple ones. Let's see. Let's see if another example similar to this. Let's suppose I get something like this: cosine theta equals negative rad 3/2. So I want to find theta. So find theta. I'm gonna do two things. Find the following. Part A will be the general solution. And then part B is the particular solutions on 0 to 2 pi. So you would use your understanding of cosine, right? You know that cosine is negative. Where is it negative? In quadrants. In quadrants 2. So theta is in quadrant 2 or quadrant 3. Now, when you do cosine inverse, so theta is cosine inverse of negative rad 3/2, you should already know you have to go back to the range of cosine inverse. What's the range of cosine inverse? The range, so recall that the range of cosine inverse are the angles from 0 to pi. And again, I know 0 to pi, I must be in quadrant 2. So what's the angle in quadrant 2 that gives me, that's associated with rad 3/2 for cosine? And that's going to be an angle that's what? Associated with the angle 30 degrees. Cosine of 30 degrees is rad 3/2. So cosine of the angle in the second quadrant whose reference angle is 30 degrees will give me negative rad 3/2. And what's that angle in the second quadrant whose reference angle is 30 degrees? It's 150 degrees, which in radians would be 5 pi over 6. So that's what you would get as my answer. And of course, this is part A. So this will be theta is equal to 5 pi over 6. And then I would add by 2 pi n, and n is an integer. But this is only in quadrant 2. I also have an angle in quadrant 3, pardon me. So if my angle is 5 pi over 6, what's going to be the angle in quadrant 3? What's my angle in quadrant 3? If my reference angle, again, my reference angle is pi over 6 or 30 degrees. So if I'm in quadrant 3 and my reference angle is 30 degrees, how do I get the angle in quadrant 3? I have to do what? I have to add pi by pi over 6, and I get 7 pi over 6. And so then my angle is going to also be in quadrant 3, which is 7 pi over 6. And I'm going to add by 2 pi n. And n is an integer as well. Any questions about this? Does this make sense, or do I need more to clarify anything? So a lot of this stuff, it might seem different than what we've been doing, but it's kind of really coming back to the inverse trig lesson that we had. So these are the general solutions. These are all the angles in quadrant 2, and these are all of the angles in quadrant 3 that satisfy this equation. And if I want to find only the angles in 0 to 2 pi, well, the only angles in 0 to 2 pi are the angles that we started with in the beginning. 5 pi over 6 is from 0 to 2 pi. And 7 pi over 6 is also from 0 to 2 pi. But do you see that the moment I add by 2 pi to one of these angles, I'm already outside of this interval, so I can't include it any further. I can't include any more. These are the only ones. So this is my particular solution. On the interval 0 to 2 pi. Okay. Next. So what if I have something like this? Rad 2 sine theta plus 1 equals 0. So I have rad 2 sine theta plus 1 equals 0. What I do is I want to solve for theta, right? So when I solve for theta, what do I get? I get sine theta is equal to negative 1 over rad 2. Now, what is 1 over rad 2? I can rewrite this when I rationalize the denominators, right? What I get is sine theta is equal to negative rad 2 over 2. So when is theta, or when is sine negative, theta must be in quadrant 3 or quadrant 4. Now, when I plug this into my calculator, when I do sine inverse of negative rad 2 over 2, what do I get as my answer? Anybody? Anyone? Negative 45 degrees or negative pi over 4, right? And that means I'm in what quadrant? I'm in quadrant 4. So then you have to go back to the unit circle. And this is the angle right here. This angle right here is negative pi over 4. And my point is what? Negative rad, pardon me, it's positive. Positive rad 2 over 2, comma, negative rad 2 over 2. And again, I'm looking only at the y value because this is sine of theta. Where else is this negative? Where else is the y coordinate negative? It's also negative in the third quadrant. Pardon me. And this is the case when you have both of the coordinates being negative rad 2 over 2. So all I have to do now is to figure out how do I represent this, part A, find general solution. So what would be one of the thetas and what would be the other theta? So again, this would be in quadrant 3, and I would have to have one in quadrant 4. In quadrant 4, I can use the negative pi over 4, but usually we write it as a positive angle. So if this is negative pi over 4 and I go in the, because I go in the clockwise direction, what if I go in the counterclockwise direction? This angle would also be equivalent or coterminal with which angle? What would be the angle coterminal to negative pi over 4? It would be what? 7 pi over 4. This is coterminal. Coterminal to negative pi over 4. So 7 pi over 4, I can use that as my angle in the fourth quadrant. 7 pi over 4 And then I'm going to add this by 2 pi n, where n is a integer. And now what's the angle in the third quadrant? What's the angle in the third quadrant that is associated with having a y coordinate or the sign being negative rad 2 over 2? If I know the reference angle is pi over 4. So this is pi over 4. So pi plus pi over 4 gives me 5 pi over 4. So the other angle is 5 pi over 4. And I'm adding by 2 pi n with the same idea. N is an integer. And so this is my general solution. Okay. And now if I want to find the particular solution, find particular solution on the interval 0 to 2 pi, what are the only angles that we have from 0 to 2 pi that would work? These are the ones. So theta is 5 pi over 4, comma 7 pi over 4. So I have two angles that represent solutions for the original trigonometric equation. Okay, guys? I hope this makes sense. I know it may seem a little strange at first because now we're doing trigonometric equations. We're solving trigonometric equations. What if I got something like this? 2 cosine squared theta minus 1 equals 0. So we're gonna probably end up just solving these kind of trigonometric equations that have squares in them. So we have so we're gonna be dealing with trigonometric equations with a quadratic style or with a quadratic nature to them, a quadratic equation nature. So again, I want to get theta, solve for theta. So I'm going to add 1 on both sides, and I get 2 cosine squared theta equals 1. So cosine squared theta equals 1/2. And of course, I'm going to take the square root on both sides. But be careful. Whenever you take the square root of anything squared, I have to take care of the plus or minus. So this is plus or minus the square root of 1/2. So I'm going to have two equations, actually. I'm going to have an equation cosine theta that equals positive square root of 1/2. And I'm going to have cosine theta with the negative square root of 1/2. And can we simplify or can we rewrite square root of 1/2? The square root of 1/2 is equal to the square root of 1 over the square root of 2, which is 1 over the square root of 2. And if you rationalize this, I get rad 2 over 2. So I can rewrite this as cosine theta is equal to rad 2 over 2, and cosine theta is equal to negative rad 2 over 2. So I have two equations to take care of. So then I have to realize, wait a minute, theta is positive. When is theta positive? Theta is in quadrant 1 or quadrant 4. When is cosine negative? Theta is in quadrant 3 or quadrant 2 or quadrant 3. You guys see that? So when you do cosine inverse of rad 2 over 2, what is theta then? What's the angle in the first quadrant whose cosine is rad 2 over 2? What is that angle? And these are the angles that you should know. Cosine of what angle gives me rad 2 over 2? Anybody? Pi, yeah, that's right. Pi over 4. And that's in the first quadrant. So this is quadrant 1. But remember, my angle can also be in quadrant 2. So what's going to be the angle in quadrant, no, not quadrant 2, quadrant 4. What's the angle in quadrant 4? Associated to pi over 4. So if I'm in quadrant 1, my angle is pi over 4. If I'm in quadrant 4, my angle would be what? Again, this is a reference angle as well. This is my reference angle. So what angle in quadrant 4 has a reference angle of pi over 4? We already did that, right? Isn't it 7 pi over 4? So what's going to be our solution? Theta is going to be what? Pi over 4 plus 2 pi n. Theta is going to be also 7 pi over 4 plus 2 pi n. Now, I'm going to be in quadrant 3 now. Quadrant 2, pardon me. And I want to find the angle in quadrant 4. Quadrant 3. So what angle in quadrant 2 gives me negative rad 2 over 2? Well, it's an angle whose reference angle is pi over 4. If I'm in the second quadrant, my angle would be 3 pi over 4. And if I'm in the third quadrant, my angle would be 5 pi over 4 plus 2 pi n plus 2 pi n. So I have a lot of angles, as you can tell, to keep in mind. And this, my friends, is my general solution. All of this. It's a little strange to write it out this way, but these are all of them. Theta could be everything in the quadrant 1. This is quadrant 1. And then everything in quadrant 4. These give me the positive rad 2 over 2 values. But from this same equation, cosine could also be negative rad 2 over 2. And these are the angles in quadrant 2. And this is in the angles in quadrant 3. So again, guys, we're going back to having to understand coterminal angles, reference angles, and the all students take calculus acronym to figure out where are the cosine negative, where is it positive. And again, reference angles here are important because once you have the reference angle, you can find out the angles for every other quadrant. So that's the general solution. And then if I had to pick a particular solution, what's going to be my particular solution on the interval from 0 to 2 pi? So if I'm just going from 0 to 2 pi, what are going to be the solutions to my equation? Well, they're going to be the solutions that I found out here. These are all the solutions from 0 to 2 pi. These are within the boundary of 0 to 2 pi. So that's going to be my solution is going to be pi over 4, comma 3 pi over 4, comma 5 pi over 4, comma 7 pi over 4. And that's my particular solution. Okay, so the solution to the equation 2 cosine squared minus 1 equals 0 is going to be anything inside here. If you want to talk about just what are all of them, these are all of them. Of course, n is an integer. And if you want to find specific ones within the interval from 0 to 2 pi, well, we have 4 different solutions. We have one angle in quadrant 1, quadrant 2, quadrant 3, and quadrant 4 that all satisfy our equation. Okay. All right. So now we're gonna raise up the level of difficulty when we deal with problems like this one. Now we're gonna have a much more sophisticated equation, trig equation. 3 sine squared minus sine theta plus 2 equals 0. I want to find theta. Find a general solution for theta. General solution. And I want to find the particular solution on 0 to 2 pi. So what do you recognize here? Or what could we do? You know what we're going to do? We're going to say this. Let x equal sine of theta. Now, why do I do that? If you notice, this here can be written as x squared. And this here can be written as x. So now look what we got. We got 3x squared minus 7x plus 2 equals 0. Now look what we have in the second equation. In the first equation, we have a trigonometric equation. In the second equation here, we have a quadratic equation. Now, how do I solve this quadratic equation? How would you guys solve this? How do you solve any quadratic equation? Well, you can use the quadratic formula, or use the AC method. And in this case, 3 times 2 is 6. What multiplies to 6 but adds to -1? Well, it's -6 and -1, right? So I can write this as 3x squared minus 6x minus x plus 2 equals 0. Now at this step, I can factor by grouping, and I get 3x parentheses x minus 2 minus 1 times x minus 2 equals 0. Then I can factor out the x minus 2, 3x minus 1 equals 0. Plus 2, right? 3x minus 1. And then what do I get? I get x equals 2, and I get that x equals 1/3. But of course, I never started with x, right? What did I start with? I never started with x, I started with theta. So I have to replace theta back. So instead of writing x equals 2, what am I going to write? I'm going to write sine theta equals 2. Instead of writing x equals 1/3, what am I going to write? Sine theta equals 1/3. And now look what I have, guys. I got two smaller trig equations that I've done in the beginning. Okay. Now, Hold on 1 second. 40. Let me just see one thing. -6, -1. 3x, x minus 2, x minus 2. Trying to check if I wrote everything correctly. 3 sine theta. Looks like I did. Okay, so then once we have this here, we have to check each of these equations individually. So what's my first equation? Sine theta equals 2. And what's my second equation? Sine theta equals 1/3. And what about the first equation, guys? Does the first equation have a solution? Sine theta equals 2. If I solve for theta, right? So if I do this, theta is equal to sine inverse of 2. What do I get? I get an error. Why do I get an error? Did you expect that, or was that a surprise? Wasn't I supposed to not get an answer for this? The reason why I get an error is because sine can never be bigger than 1. So this actually has no solution here. This actual equation has no solution. And now what do I get for this? Sine theta equals 1/3. So theta is equal to sine inverse of 1/3. Or arcsine, right? You can also write this as arcsine. Arcsine of 1/3. Now, this angle here, we don't have a reference angle that the ones that we know, right? For example, we don't have 30 degrees, 45 degrees, or 60 degrees, or 90 degrees. None of these angles here work because we don't have anything that gives us just 1/3. That's so nice, like the ones that we know. So this is a scenario where we have to use our calculator for this. If you use arcsine, just to give us an idea of what this actually is, if you do second inverse of 1/3, in degrees, this is 19.47 degrees. So again, what's going to happen for this, guys, is that this is the exact value, okay? This is the exact value. And this here is an approximated value. And what I'm going to be interested in is in the exact value, not in the approximate value. And because this is positive, this is a positive angle. So theta, this angle, as you can tell, is in quadrant 1. This is in quadrant 1. So if I'm in quadrant 1, what's my theta? My theta would be arcsine of 1/3, which is 19.47, right, in degrees, plus 2 pi n. That's going to be all my angles in quadrant 1 that make this work. And now, where else is sine positive? So you have to always remember that. So theta is in quadrant 1 or in quadrant 2. So if I'm in quadrant 2, how do I get quadrant 2? So drawing this might help again. So quadrant 1, right, this angle here is sine inverse of 1/3, which is 19.47 degrees, which this represents a reference angle. This is my reference angle. Now, if I want the angle to also be in quadrant 2, what must I do to get the other angle? What must I do to get this angle here? I must do what? This angle is going to be what? Pi minus arc sine of 1/3. It's going to be pi minus the reference angle. So my other angle here is going to look a little strange, but it's going to be pi minus arc sine of 1/3, right? This angle here is in quadrant 2. It's the actual angle in quadrant 2 whose reference angle is arc sine of 1/3. And then I'm going to add by what? I'm going to add by 2 pi. And this here is my general solution for this equation that I originally had, which is a trigonometric equation that has a quadratic nature to it. So if I plug in arc sine of 1/3 in here, I'm going to get a solution. If I plug in pi minus arc sine into each of these angles, also going to equal 0. If I plug in arc sine of 1/3 plus any integer multiple of 2 pi and I plug it in here, also same thing. If I plug in pi minus arc sine of 1/3 and I add any integer multiple of 2 pi and I plug it in for theta, again, it also works out. So that's the idea. That's part A. And then part B asks for what? It asks for the particular solution on 2 pi, 0 to 2 pi. But again, I only have two solutions from 0 to 2 pi. I only have two solutions whose angles are from 0 to 2 pi, which is in quadrant 1 and quadrant 2. So theta is going to be equal to arc sine of 1/3 or sine inverse of 1/3, either or. And then I'm going to have pi minus arc sine of 1/3. So those are my two solutions from 0 to 2 pi, and these are all of the infinite number of solutions. So this is the case, guys. Not only is this strange in terms of it's a quadratic equation, really, the other strange thing is that the angle that I get is not a typical angle that we've gotten in the previous ones, right? These are the nice ones. These are the ones that we know. These are 7 pi over 4. We got, what else do we have? We have 5 pi over 6, 7 pi over 6. So these angles are the ones that and pi over 3. You see that? Pi over 3, 2 pi over 3. These are the angles that are quote unquote nice. We know these reference angles. But of course, not everything in this lifetime of ours is always so clear and neat. Most of the time, we have these kind of situations where the equation that we get is not something that we typically see. We don't typically talk about sine theta equaling 1/3. We typically talk about sine theta equaling rad 2 over 2 or rad 3 over 2 or 1/2. But the moment we have another type of fraction, which is something we've never seen before, then we have to use this idea of arc sine and leave it as arc sine or sine inverse. Okay? So that's the idea. So let's do one more and then we can call it a semester. I think this one here, the answers will be a little bit cleaner. So 4 cosine theta squared minus 4 cosine theta plus 1 equals 0. So we have another quadratic. This time it's a quadratic with cosine in them. So I'm gonna let x equal cosine theta. So when I do that, my new equation becomes 4x squared minus 4x plus 1 equals 0. And I want to solve this quadratic. When I solve this quadratic, what do I get? 4 times 1 is 4, positive. What multiplies the positive 4 but adds the negative 4? They both have to be negative 2's. So this becomes 4x squared minus 2x plus 1 equals 0. Then you factor by grouping, and I'm left with 2x times 2x minus 1 minus 1 2x minus 1 equals 0. This is a Pythagorean. This is a perfect square trinomial, so I should have known that this already would give me 2x minus 1 times 2x minus 1 squared equals 0. Pardon me. And this you can rewrite that as 2x minus 1 parentheses squared equals 0. Now the only way this equation is true is if the inside of the parentheses 2x minus 1, this has to give me 0, which means that x must be 1/2. So the only solution for this is if x equals 1/2. But remember, what does x represent? X represents cosine, so I really have this. I really got that cosine theta equals 1/2. And what angles give me 1/2 for cosine? Cosine of what angle gives me 1/2? So when I plug this in, theta is equal to cosine inverse of 1/2. What angles give me 1/2 for theta, for cosine? And again, this means that theta must be what? Theta is in quadrant 1 or quadrant 4. That must be it. 60 degrees, that's correct. So theta has to be 60 degrees, and radians, that's pi over 3. I add by 2 pi, and that gives me all of the angles in quadrant 1. But I also have to be in quadrant 4. So what angle in quadrant 4 has a reference angle of pi over 3? So if I'm in quadrant 4, my reference angle is pi over 3. The other angle would be what? 5 pi over 3. Right? This is the angle in quadrant 4, whose reference angle is pi over 3, which is like saying 300 degrees, right? 300 degrees is in quadrant 4, whose reference angle is 60 degrees. And then I'm going to add this by 2 pi n. And this represents the general solution, meaning that this represents all the solutions, which are infinite number of solutions for the equation. And if I want to find a particular solution, on, and I have to specify the interval on 0 to 2 pi, I want to find all the angles within first 4 quadrants that satisfy my equation, and the only ones that do that are going to be pi over 3, which is in quadrant 1, and 5 pi over 3, which is in quadrant 4. Okay.